Greetings everyone, this is Nazamin Sheikh. So without any further delay, let's start with the topic of Mealy and Mealy machine. First starting with what is FSM. So an FSM is a machine that has many states and has a logical way of changing from one state to another under guiding rules. There are many types of FSM in which Mealy and Mealy machine are output oriented. Mealy is output oriented on the transition state, whereas Mealy is output oriented on the state. Mealy machine, it is an FSM whose output depends on the present state as well as present input. In Mealy machine, every transition of a particular input symbol has a fixed output. Mealy machine can be described by the following six tuples: finite state, finite symbol, finite symbols for the output alphabet, input transition function, output transition function, initial state from where an input is processed. All these states have a different tuple basically representing them. Now, let's look at the construction of Mealy machine. So, according to the question, let's construct a Mealy machine that takes sets of all string over set AB as input and construct the occurrence of substring BAA. For this, so we will normally take a normal NFA structure in which we put the output on the state as follow. So we have constructed the NFA and now we put on the output alongside with the state, and now we will complete the transition according. On the first circle we can put A alongside with the output, no sorry, no output will be there as we are constructing Mealy machine. A, now B can be put it here only, and now we will move a Q2 to Q1 with B and Q3 to Q1 with B state and Q3 from A, and now this is how we will construct a Mealy machine. Moving on forward with Mealy machine. Mealy machine is an FSM. The value of output function is dependent on the present state only. Mealy machine is described by following six tuples: finite non-empty set of state, sets of input alphabet, sets of output alphabet, transition function mapping, output function state, and the initial state. And the six symbols represent the following as I have described. Now, before moving on to Mealy machine conversion, let's see the construction of the Mealy machine that takes the set of string AB as an input and counts the occurrence of substrings A and B or ABB. Let's go. Now, moving forward for the same example as Mealy machine. So I will repeat the question. So construct a Mealy machine that takes sets of all string over AB as input and construct the occurrence of substring BAA. So normally here also we will construct a NFA, or you can say DFA, with BAA as the basic part, and now we will putting the output alongside with the transition state, and we will be now completing the whole state, or we will completing the movement of B alongside with A where the all the states, so that all states are complete. And this is how a Mealy machine for the given question is being constructed. Now let's get back to Mealy machine to Mealy machine conversion. You can go through the following step, but going through a step is basically a harsh way for doing an automata. So let's look at it with an example. Now moving forward to Mealy conversion, let's take the following question. Let's see on the screen, which is basically state 1 is x naught, x present with the output O, y with the output 1 and Z with the output 2. So for solving this question, firstly we will be making a transition table. So in this transition table, the first step is to place out the output states, basically which are 0, 1, 2, and the transition which is 0 and 1. So X is having the output as 0, Y is having output 1, and Z is having output of 2. Sorry for my handwriting there. And X on 0 transition is using X, X on 1 transition is using Y. Accordingly, for the following elements, I have written the transition table. Now, it's simply converting the Moore table to the Mealy one. We will put the 0, 1 state and XYZ, along with we will putting XYZ same as the table. Put the now we have written the elements. Now putting the output accordingly, like Y was having 1 and sorry, here was a mistake, and Z was having 2. So we will be completing this accordingly. And now we have made our table, transition table. So now we'll be constructing the Mealy machine from out of it. So XYZ, and we know Mealy is having transition output on the transition. So we will be doing the same. So X is on 0 is having an output 0. So accordingly, and on X on transition on 1 is moving towards Y. So accordingly, same will be done to solve the following question from the table. And that's how we reach our final answer. Now let's see Mealy machine to Moore machine conversion, and let's go to the example part or the demo part directly. Now moving forward, last question, which is basically moving forward to our last question, this is basically Mealy to Moore conversion. For this we will be taking the last example only, and here we will be constructing the Mealy transition table first. As we have already made the Mealy transition table, it's quite easy for us to make it here. We will taking the states along with side the transition 1, or you can say the output 1, and we will simply writing down. So take a look on the screen. It's quite easy to understand when you are basically listening as well as seeing what is happening. So after we had done with the transition table, now we will convert or make the Moore table also. So we have already done it. So you can see that we will be making the XYZ and then putting the output state alongside the X. The output is 0, Y is having 1 and 2, and simply putting down the value of 0 and 1 like X, X, Y, Y, Z, X and YZ. Now constructing the initial state with the output, like X having 0 on the state, Y with 1 on the state and Z with 2 on the state, and then completing the whole transitions. And we will then reach our final answer. So this is the final state after converting the Mealy which was given to Moore. There are many differences between Mealy and Moore states machines, mainly described in the screenshot attached. Mealy machine changes its output based on its current input and present state, whereas Moore machine changes the output depending on the current state and not on the current input. Mealy machine is a representation point of view. Output is placed on the transition state, whereas on the Moore machine it is placed on or the alongside with the state. Mealy machine is faster, whereas Moore machine may be faster to use because they change state on the clock edge. Mealy machine is faster and Moore is predictable. And similarly, other advantages and disadvantages are along with Mealy and Moore. You can go through it with the attached screenshot. Moving forward with the advantages of Mealy machine and Moore state machine. Moore machine are cheap, they are easy to use. Moore state machine are very fast. Mealy machine are reactive, which means they have low response time, aka they are fast. So disadvantage of Mealy machine and Moore state. Mealy state machines are expensive to produce. Number of states can become unmanageable or can become very large. Finally, we have reached the conclusion part of our PowerPoint presentation. Both state machines are very important concept in digital design, and these machines can be used in the design of mathematical algorithm. Mealy and Moore state machine can come in both simple and complex type. So let's look at another example on how to construct a Moore machine. So let's look at the question. So let the question be: construct a Moore machine that takes sets of all string over AB as input and prints 1 as output for every occurrence of AB as a substring, otherwise 0. So we will basically first construct the states. So let the first state be Q0, and then the second state be Q1, and then Q2, the final state, and the string will be AB. So as we know, Moore machine, the outputs are present on the state itself. So when we get on the Q0, we will be getting the output of 0. After getting an A, we will be getting state as 0 as an output only, and after getting AB string, we will be getting the output 1 on Q2. So we have done the first step. Now completing the state on the first state, the transition of B will occur, and same as if we put A on Q1, the string will be same as the last string will be AB only, and AB will be occurring. And then on for the final state, we can simply place A here and B like this, and voila, we are done with the construction of Moore machine. Now moving forward, let's look at the construction of Mealy machine with the same example. So once again I will repeat the question. Construct a Mealy machine that takes sets of all string A, B as input and prints 1 as output for every occurrence of A, B and 0 otherwise. Now we will constructing same. First we will constructing a normal NFA. So Q0, and here will pass A, and Q1 will passing B, and then we will reaching the final state only. Now in Mealy machine, we know that the output is oriented with the state, or sorry, with the transition only. So when A has occurred, the output will be 0. When AB has occurred, the output will be 1. Now for Q0, in the Moore machine, it was B. Same here also, it will be B with an output of 0. And for Q1, it will be same as the Moore machine. Here it's A with output of 0. And for Q2, A with output of 0. And from Q2 to Q0 has B as output of 0. And we have also constructed the Mealy machine also. Now let's look at the conversion of the same question that we have done in the previous Mealy and Moore. But this time let's directly convert this. So now looking at Moore to Mealy conversion. So the question was as follow. Let me write down the question. Q1 with output as 0 and Q2 as output as 1. Sorry for my bad handwriting. And here the state was B, here the state was A, here the state was A, and transition it was B. So this is the question. Now we will converting it directly. So I guess you have observed previously in the examples only. That's why I was taking the same example each time. So So now let's construct the basic structure first, like Q naught was state, the transition of A, then Q1, the transition of B, then Q2. Now the first part is done. Now we're constructing all the transition one, like B transition was here, A transition was here, and then A occurrence was also here, and B was occurring here. Now, as B was moving towards state Q naught and the output was 0, so we'll be placing B with 0. A was moving to Q1 and the output on Q1 was 0, so we'll be placing A alongside with 0. Again, here A was moving to Q1, the output is 0, so placing A with 0. B was moving toward Q2 and the outputs were 1, so we'll be putting B with output state 1. A was moving towards 0, so it's 0, and B was also moving towards 0, so B is also to 0. And thus we have constructed, or we can say converted, Moore to Mealy successfully. Now, moving toward the conversion of Mealy machine to Moore machine. So we will taking the same question. So here our question is, now let's directly convert this one also. So the first state was Q naught, and we know that in Moore the output is on the state, so we will building the circle a bit more, so we can write this here and some space is left with us. And then there is Q1 and then there is state Q2. Now AB transition was there, the state was transition as B, second state transition was as A, the third transition was A, and the transition was here as B. We're done with this. Now we'll go observing, like when B is moving towards Q naught and here also B is moving towards Q naught, the both output producing are as 0. So we'll move to the conclusion Q naught is on Q naught state is having an output as 0. Now when B naught, A naught is moving towards Q1 and the same state A naught is moving towards Q1, the output is occurring as 0, so Q naught is having a state of 0. And also here A naught is moving towards from Q2 to Q1, the output is 0, so hence Q1 is 0. Now only B1 is moving to Q2, and when B1 moves to from Q1 to Q2, on the transition B1 it's having an output of 1, thus Q2 will having an output of 1. Hence, observing this, we have successfully converted Mealy to Moore. I end my presentation. Thank you for listening and being through the whole presentation.